Ready. So the story is there's a little guy who's trying to do a backflip. What he does is he falls on his face. Am I allowed to present the backflip? No. No. Present the backflip.
You can present the backflip.
Oh.
Oh God, you're really gonna present the backflip. Okay, how about you do that at the very end?
Okay.
There we go. We just got a fancy new piece of equipment. We don't want to break it.
Explain.
Alright, so as you see he starts off, I guess he was dancing at the beginning from 0 seconds to 4 seconds. And then this is from here to here. This is position versus time graph. And then so he begins to crouch right here from 0.4 seconds to 6 seconds. And then so right then he begins to jump off from the ground at 7 seconds, I guess, and takes off at 8 seconds. And then around this point right here, he does his little backflip in the air, and then starts to fall face forward towards the ground. And then so at 14 seconds, his face hits the ground and immediately stops. And then takes right back and then jumps up from the ground at 16 seconds.
Okay.
And then this is our velocity versus time chart or graph. So right here, when he's like little dancing or whatever, it's just a constant velocity. Then when he begins to crouch, it's a negative velocity. And so once he takes off for the jump, it becomes positive. And while he's landing, he goes straight down to a negative velocity. And when he hits the ground, it's a sudden stop. And so that's why we have a hole, because he hits right back up as soon as he
And
gets
it
there.
becomes positive because as soon as he hits the ground, he's coming from a negative slope. So as soon as he hits the ground, it changed from negative to positive because he jumps right up after he hits the ground. And the reason because in this loop right here that he's jumping, his fastest speed is in the middle of the jump. So this is right around the middle of the jump. That's why it's so high. Compared to when he starts off, he's getting faster, and when he gets closer to his highest point, he's slowing down. Yeah, and then our measurements for velocity from 5 seconds to 7 seconds, he is crouching, and then from these 2 points, which is, I think this was 8 to 10, he was jumping in the air, and then this is when he falls, and this is of course when he hits the ground with his face.
Okay, so you guys are hinting towards some really cool math terms, so let's try to get some of them in there. So you're talking about velocity changing from positive to negative, and when he hit his face in the ground, that you have a hole. So that's a great start, but let's try to use some of that vocabulary that we were using in class. So when our velocity is changing from negative to positive, what's actually happening?
It's like the slope or it stops.
It's negative. You said when it changed from negative to positive? Like,
Yes, you're telling me that his velocity was negative because he was crouching, right?
Uh-huh.
And then it went positive. So what do we call that? When his velocity, remember we did like the facial gestures?
Oh,
So if it went from negative to positive,
concavity.
well, it's not concavity, it's the what?
Inflection.
It's either the max or the min, right?
Oh.
The maximum. Yeah.
These are like the lowest point.
Uh-huh.
Yeah. So this would be the max. And I mean this would be the minimum, one of the minimums, and this would be one of the maximum. That's why right here it passes to 0.
What passes at 0? Let's make sure we're talking about the right graph.
But this,
So when his position is 0,
uh-huh.
what happens for his velocity?
That's what this is.
Or sorry, not when his position is 0. When his position is at the lowest,
Oh,
what happens with his velocity?
he passes the x-axis.
Which means what? What's his velocity there? 0. So when his position is at its lowest, his velocity is 0. What happens when he's at the top of his jump?
His velocity is 0 too.
Why?
because he's not moving, I guess. I guess he's floating in the air for a brief millisecond.
Yeah, so it's kind of like, remember AJ's jump, guys, where he like did the freeze frame at the top? Same idea. So then let's talk about the face plant into the sidewalk, because that's another crucial part of the story. What happens in your graph there?
Alright, so there's a hole because of, I guess, the change in his velocity. So his velocity is negative when he starts to fall from his jump from right here, because he is constantly increasing towards the ground, well, constantly increasing negatively until he hits the ground. And I guess he tried to like play off his fall, and so he jumped straight up, causing it to come from the negative to the positive side, making him go straight forward. The reason that it's a hole is because of
Think of the homework we just did last night.
Does not exist.
Does not exist, so it's a discontinuity, right?
Yes.
So that's from the homework last night. You have that extreme change in position where it meets at like the cusp or the point. It's discontinuous, so that's when you have the hole. So a round of applause for these gentlemen. They did a great job.